Hey guys, Dr. Leslie here. Um, we are here today doing an e-value question. This is really a test video. I wanted to just upload it to see if this is the format I want to do, but my goal is to put up some really helpful videos that pertain to 2025 NAPLEX calculations type questions. And I don't know if I want to call it calculation for the non-genius pharmacist or something like that, because it seems like the videos that are out there are a bit cold and hard to follow. At least I think so. So let's see if I can make this a little bit easier for the pharmacist that's trying to pass the NAPLEX, or someone in pharmacy school, or whatever. I feel like this type of math could pertain to. So this is an e-value question. How do we know it's e-value? Well, words like make isotonic tells you it's probably an eye drop or it could be an injection. I can't really tell. But here, sodium chloride equivalent is, the otherwise known as the e-value. So if they give you that, obviously this is going to be an e-value type math problem. So let's read the question. Step one is always to read the question and then looking at the whole left side of the case. In this particular situation, we don't need it at all. What we need is up here. So don't get distracted. That's kind of tip number one in a case-based question on the NAPLEX, especially if it's math, because it may not involve any of this. It's just there, and it's easy to get sucked in to that side, but don't. All right. So step one is how much sodium chloride would make this particular prescription isotonic without mixing anything in it except sodium chloride, normal saline. Yet we're making 3 mils. So ask yourself, okay, how much sodium chloride in the form of normal saline would make 3 mils isotonic? This is the way I do it. I like to do dimensional analysis, and so my brain just kind of thinks that way, but you could do it ratio for step one as well. We have 3 mils. Normal saline is always zero point 0.9 grams per 100 mil. This matches our body's salt makeup essentially. So therefore, you won't have issues with hypertonicity or what's the low hypotonicity, where like water might shift and think bad things could happen in the body. As long as you keep it neutral like this, then yeah, that's the point of it. Mils will cancel out. So 3 times zero point 0.9 divided by 100 is going to be our step one. And we're in grams. So pay attention to what unit you're in and then notice what unit they want you to finish in. Here it's grams. So that's a mismatch. We'll have to address it at some point. So 3 times zero point 0.9 divided by 100 is 0.027 grams. Since my answer is supposed to be in milligrams, to avoid confusion, I'm just going to go ahead and change this to milligrams, but of course, it's not the final answer yet. So times 1,000 is 27 milligrams. I shouldn't cover up my face because I'm used to covering it up for my pharmacy classes. So I have more space, but I'm going to keep it here for a YouTube video so you can see my face, even though I have no makeup on and my hair not done yet. This is just a test. All right, we've got 27 milligrams of sodium would make this isotonic. But that's not the end. We're going to add pilocarpine to this eye drop or injection, which contributes some sodium. But how much is really what we need to figure out. And then we're going to subtract it from what it would take sodium chloride in sodium chloride terms to make this isotonic. So if this 3% were in grams or in milligrams, we could multiply it straight by its e-value, but it isn't, it's in percent. So we're going to do a similar step to what we did in step one, but this time it's 3 mils of a 3% solution. How many grams of pilocarpine are in 3 mils of a 3% solution? So 3 times 3 divided by 100. I should be able to do that in my head. 0.09 grams. Let's change it to milligrams to match our units. 90 milligrams. Now, before we go and subtract 90 from 27, we have one more step. We have to get this in sodium chloride terms. Right now it's in pilocarpine terms. So we're going to multiply 90, step 3, multiply 90 times its E value, pilocarpine's E value, 90 milligrams times an E value of 0.24. You will keep, like, as long as you're in weight, grams or milligrams, it will stay in the same unit. So 90 times 0.24 is 21.6. 21.6 milligrams. Now we can subtract this. This is how much milligrams of sodium chloride that pilocarpine contributes. So let's go back to our question. How many milligrams of sodium chloride would render this compound isotonic? It would have been 27, but not anymore. Now we have 21.6 to account for in the pilocarpine or with the pilocarpine ingredient. So we're just going to subtract minus 21.6 is 5.4 milligrams of sodium chloride is remaining to be fulfilled. So it's D. The person who did this and sent to me, they put A. A would have been correct had it asked us to answer in grams, but it didn't. So watch for that. And watch what they're doing. And it might be fill in the blank on the NAPLEX. It very well could be. But if they do give you answer choices, they'll very likely give you an answer choice that could make sense if you made an error, one little error. Yeah. So tune in for Dr. Leslie's next video with hair and makeup done for pharmacy math for the non-genius. Peace out. Bye-bye. Like and subscribe. Bye.